Hi guys, this lesson is on the quadratic formula. So today we're going to be talking about how to solve quadratics using one more method. So this formula at the top here, this negative b plus or minus the square root of b squared minus 4ac all over 2a, that is a formula you need to know. So that is the quadratic formula. Now this formula isn't just some magic formula that we came up with. It actually comes from completing the square. So what we're going to do is we're going to actually derive the quadratic formula, and derive just means show where it comes from. And one great thing about the quadratic formula is that it's going to work all the time, just like the complete the square does. But it's a little more useful when we're working with big numbers or super nasty numbers like decimals or fractions. It's a little more useful in that regard. So let's start looking over here. So I have a problem with completing the square and I have deriving the quadratic formula. So hopefully the first thing you notice is that the only difference between the left and the right side is that the left side has numbers and the right side doesn't. So we're going to do both problems at the same time so that you can kind of see numerically what's happening. So starting with the left equation, 16x squared minus 48x plus 24 equals 0. The first thing we would do is we would take and divide everything by 16 because we want the x squared to have a 1 in front of it. This would be the same thing that we would do with our generic quadratic, our ax squared plus bx plus c. So instead of dividing by 16, we're going to take and divide every single term by a. Okay, that's the number in front of x squared. That's the same thing we did with our numbers. Now on the left side over here, when we divided by 16, we end up with x squared. Now 48 over 16, that's negative 3x. 24 divided by 16 is 3 halves. And 0 divided by 16 is 0. Okay, so when we have the numbers, it's a little bit easier to see. Now on the right side over here, a divided by a ends up being 1. So we have 1x squared, but unfortunately we can't divide b by a. So we have to just write this as plus b over a. And then instead of putting the x on top, I'm just going to put it over to the side so that it looks like our 3x. C divided by a would just be c over a. And 0 divided by a would just be 0. So notice our formula is looking a little similar now. Now that we have x squared with a coefficient of 1, our next step would be to subtract the constant. So in this case over here, we're going to subtract this 3 halves to the other side. So that would give us x squared minus 3x equals negative 3 halves. Okay, so all we did was we took this little 3 halves, we moved it over by subtracting it. Okay, now with the deriving problem, we're going to do the same thing. We're going to move the constant over. So in this case, the constant would be the CA. We're going to take the C divided by A over. To move it to the other side, we're going to have to subtract. So we're going to have x squared plus b over b over ax. That's going to equal negative c over a. Okay. Now, our next step would be to actually complete the square. So on this left side where we have numbers, we have x squared minus 3x. We're going to have to take and add something right in here to make this a perfect square trinomial. And then because we have to add it on the left side, we have to add it on the right side as well. So remember, the rule is you take half of the x term. So half of negative 3 would be negative 3 halves. And then you take and you square it. So same thing over here. We would have negative 3 halves squared. So if we go ahead and write down what that equals, negative 3 squared is 9, and 2 squared is 4. So negative 3 halves squared is 9/4. It's the same concept with our deriving problem. So notice I'm bouncing back and forth between these because I really want you to see that it's no different. It's just that here we're dealing with letters, and on the other side we're dealing with numbers. So it's the same concept. We're going to have to take half of b over a. Now when we take half of it, that simply means that we're going to come over here and do 1/2 times b over a. So 1/2 times b over a is simply b over 2a. It divides it by 2. And then we square it. Okay, so half of b squared, And then we're going to write the same thing on the right side, but I'm going to go ahead and simplify it. So b squared is just b squared. 2 squared is 4, and a squared is a squared. Okay, so all I did was take and I gave this square to the b, to the 2, and to the a. Okay, so that's all that's happening in that problem when I'm multiplying things out. So now I have perfect squares on each side. So back on my left problem with the numbers, remember we would just shortcut this and say x minus 3/2 squared. Because the x comes down, the negative 3/2 comes down. If I square that, it would go back to x squared minus 3x plus 9/4. It's the same thing over here. Okay, we'd bring the x out, we'd bring down the plus b over 2a, and we would square it. So notice we have a little bit nastier problem, but it's still done the same way. Now, over here on the 16x squared problem, we have to combine negative 3/2 plus 9/4. Now, if you'll recall from your fraction rules, that means we have to get the same denominators to add these. So 2 and 4, the common denominator would be 4. Okay, so 9/4 is just 9/4. I didn't have to multiply 4 by anything to get it. But I had to multiply this half, this 2, by 2. So that means I have to multiply the negative 3 by 2 as well, giving me negative 6. Remember, negative 6 over 4 would simplify to negative 3/2, which would then give me x minus 3/2 squared equals, well, negative 6 plus 9 is 3/4. Okay, and that's important to understand because over here on the other side, we're also going to have to get common denominators. So I have an a and I have a 4a squared. I need to be able to make them the same number. So what that means is I can actually multiply this a at the bottom here, down here, by 4a. And by doing that, I would end up with 4a squared. Okay, so that's all I'm doing is I'm trying to get the same denominator, so 4a squared. So if I multiplied the a by 4a, that means I have to multiply the c up top by 4a. So that becomes negative 4ac. All I'm doing is multiplying top and bottom by 4a. And now the 4a squared for the second term, b squared over 4a squared, is already the same. So I just can write down the b squared like it is. Okay, so this fraction right here didn't change anything because it already had a like denominator. This one over here I had to manipulate to make it look like negative 4ac over 4a. Okay, so now that I have that, now I can actually add them. So x plus b over 2a squared, that didn't change. Over here, common denominators, the common denominator is 4a squared. So then I'm going to add negative 4ac plus b squared. Now I will tell you we don't typically put it in that order. We typically would put the b squared first. So I'm just going to simply erase this and make it b squared first. And hopefully you're starting to see our quadratic formula pop out. So notice up here we have a b squared minus 4ac. So it's starting to look a little bit like what we have. Okay, now back to our normal problem, our number problem. The next thing we would do is we take the square root of both sides. Okay, so guess what we're going to do with our letters? You guessed it, the same thing. We're going to take the square root of both sides. Again, a little bit messier with all the letters. Okay, so if you remember, going back to our numbers, when we take the square root of both sides, that creates the absolute value of x minus 3/2 equals, okay, so we would have the square root of 3 over the square root of 4. But remember, the square root of 4 is simply 2. So I'm going to have the square root of 3 over 2. Okay, so now on my variables, my deriving problem, same concept. The left side would simply be the absolute value of x plus b over 2a. Now the right side, we can't take the square root of b squared minus 4ac because we don't know what that equals. So we're just going to write it as the square root of b squared minus 4ac. However, we also have the square root of 4a squared on the bottom, but just like over here, 4 was a perfect square. So over here, this 4 was a perfect square. 4a squared is also a perfect square. So instead of putting the square root of 4a squared, I'm going to erase that, and I'm going to put 2a, because 2a times 2a is 4a squared. Okay, so now we have to break it out of the absolute value. So on the left problem, we're going to have x minus 3 halves equals plus or minus the square root of 3 over 2. Well, same concept over here. X plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Now our final step is to move whatever's with the x to the other side by adding or subtracting. So over here we'd have to add 3 halves. So x equals positive 3 halves plus or minus the square root of 3 over 2. Over here we would have to subtract. So minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, the very last thing that we do, we don't typically do this, we usually just leave them apart, but the quadratic formula, we want it as simple as possible. So if they have the same denominators, like here we have 3 halves plus or minus the square root of 3 over 2, these denominators are the same. So what that means is we could actually put this together in one single fraction. So we could say 3 plus or minus the square root of 3 all divided by 2. And that could be our final answer. Now, this answer is just as good, but the reason I'm doing it this way is because over here, when I'm deriving the quadratic formula, we do actually put them together, because these right here are the same but common denominators. So we're going to have them all over 2a, and on top we would just write negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is where our formula comes from. Okay, it doesn't just pop out of thin air. It's actually mathematically derived. Okay, so now we're going to use it really quick. So number 1 here at the bottom, we are going to have the equation x squared plus x minus 6 equals 0. So x squared plus x minus 6 equals 0. So the first thing we are going to do is we're going to write our formula. So x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. Okay, so now that we have our formula, we're going to identify these a, b, and c. So a, b, and c is what we have to fill into our formula. Our a is always in front of our x squared. So remember, we're looking at ax squared plus bx plus c equals 0. So this equals 0. That's a good thing. So a would be the number in front of the x squared. It would be the 1. B would be the number in front of the x term, the linear term. So it would also be a 1. And c would be your constant. So this would be negative 6. Okay, so now we're going to fill in our formula. So we're going to have x equals negative b, so negative 1 plus or minus the square root of 1 squared minus 4a is also 1. C is negative 6 all over 2 times 1. So then we have x equals negative 1 plus or minus the square root. Now we're going to clean up the inside. So 1 squared is 1. Negative 4 times 1 is negative 4. And then that times negative 6 is positive 24. All divided by 2 times 1, which is 2. So x equals negative 1 plus or minus the square root. Well, 1 plus 24 is 25, all divided by 2. All right, so now we know the square root of 25 is 5. So we have negative 1 plus or minus 5, all divided by 2. So now our last step is to break this apart into the two pieces. So this is negative 1 plus 5 over 2 and negative 1 minus 5 over 2. Okay, so negative 1 plus 5 over 2 is going to be 4 over 2. Negative 1 minus 5 over 2 is negative 6 over 2. Oops, sorry, that's 2. So 4 over 2 equals 2. Negative 6 over 2 equals negative 3. So our solutions are x equals negative 3 and positive 2. Okay, so those had nice integer answers. So let's jump over to number 2. Okay, so number 2, the problem is going to be 3x squared minus 4x equals 0. So again, we need to make sure it's in standard form. So since it equals 0, it is in standard form. X squared is first and then x. So our next step is to identify our a, our b, and our c. Okay, so the a is in front of the quadratic term, so our a is going to be 3. It's in front of the x squared, right there. Our b is going to be in front of our linear term, so in front of the x, so that's negative 4. And our c is our constant. Now this particular equation doesn't have a constant, so that means our c is simply 0. So now, writing our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and we fill in the values. So our values would be x equals negative. Now I am going to put double negatives here because that's going to create a positive 4 in just a minute. And then I'm going to have negative 4 in parentheses squared. You have to put the parentheses around it. Minus 4 times a is 3 and c is 0. All divided by 2 times a, which is 3. 2 times 3. So now we're going to clean it up. So I have negative negative 4, which is positive 4, plus or minus, well, okay, I have negative 4 squared, which is positive 16. And then this expression right here equals 0 because I'm multiplying by 0 right there. So I just have a 16 underneath the radical. And then underneath on the denominator, we'd have 2 times 3, which is 6. So again, finishing this problem up, 4 plus or minus 16 is a perfect square. So now we simply break it apart. We have 4 plus 4 over 6. We have 4 minus 4 over 6. So this is going to equal 8 over 6, which is 4/3. This is going to equal 0 over 6, which is 0. So our solutions would be 0 and 4/3. And you can leave it as an improper fraction as long as you simplify it. So let's look at number 3 now. 5x squared minus 2 equals 0. So again, is it set equal to 0? Is it in standard form? The answer to both of those is yes. So now we identify our a, our b, and our c. So our a is going to be in front of the quadratic, x squared. So our a is 5. Now notice this time we don't have an x term. There's no bx term. So really this is 5x squared plus 0x minus 2 equals 0. So our b is going to be 0 and our c is going to be negative 2. So when we fill this into our formula, which we need to write, x equals negative b plus or minus the square root b squared minus 4ac all over 2a, we're going to plug a 0 in for b. So x equals negative 0 plus or minus 0 squared minus 4 times 5 times negative 2. And that's all going to be divided by 2 times 5. So one thing you'll note is the only variable here, a, b, and c, that won't be 0 at any time is the a. And that's because you have to have an x squared term for it to be a quadratic. So b could be 0, c could be 0, and if they are, it makes the problem a little easier. So like on this one here, negative 0 is just 0, plus or minus. Well, if that's 0, I'm not going to write that down, But now I'm going to take and multiply. Negative 4 times 5 is negative 20, times negative 2 is going to be positive 40. So I have 40 inside, all divided by the number 10. Now, I don't actually need this 0 here. So 0 plus or minus the square root of 40, I can simply write this as plus or minus the square root of 40 over 10. But the square root of 40 has a perfect square in it. So remember, 40 would break down into 4 times 10. So this is actually going to be x equals plus or minus 2 square root of 10 divided by 10. But we're still not quite done, because look at this 2 over 10. That can simplify. So our final answer is going to be x equals plus or minus 2 divided by 10 is 1/5. So I have a 5 on bottom, and I have 1 square root of 10 on top. So I'm just going to write the square root of 10. And that would be my final answer. That answer is irrational, and we do want to leave it as a simplified radical. Okay, number 4. 4x squared plus 8 equals negative 2x. So hopefully the first thing you've noticed with this problem is that it's not in standard form. So the first thing we're going to do is move the 2x over. So 4x squared plus 2x plus 8 equals 0. Notice I didn't just put the plus 2x anywhere. I put it between the 4x squared and the 8. I need it right in between there because that puts it in standard form. So now my a is going to be 4, my b would be 2, and my c would be 8. So filling in our formula, hopefully by now you have it memorized. If not, no worries, we're going to sing a song tomorrow. So we're going to fill this in now. X equals negative 2 plus or minus 2 squared minus 4 times 4 times 8, all divided by 2 times 4. So x equals negative 2 plus or minus. All right, underneath this radical I have 4. So then I have 4 times 4 times 8. So 16 times 8 is 128. So I have 4 minus 128. And notice I know it's a minus because I have 1 minus and then 2 positives. And that's going to be divided by 8. So x equals negative 2 plus or minus the square root of negative 124 all divided by 8. Now there's a couple of things we got to work with here. One, we have a negative underneath this radical. Once upon a time we would have said no real solution and been done. But now we have complex numbers. So what that means is we can simplify this down a little more. So I have negative 2 plus or minus. So remember the I comes out for the negative. The square root of a negative 1 is I. And then we need to take care of 124. So I need to see if there are any perfect squares in 124. And the fact that it divides by 4 and 31 tells me that there is a perfect square of 4. So that means the 2 is going to come out. So this square root of 124 actually equals 2 square root of 31. So instead of just putting an I there, I'm going to put 2I square root of 31 all divided by 8. Now, you might think we're done. We still have one little problem. Notice these values right here. This 2, and this 8 can all be divided by 2. So what that means is I need to simplify. So this becomes negative 1, because I'm going to divide 2 by 2, plus or minus 2 divided by 2 is another 1, I, square root of 31, all over 8 divided by 2 is 4. Now we don't typically write the 1 in front of the I, so I am going to erase it, and this would be our final answer. Negative 1 plus or minus I square root of 31 divided by 4. So number 5, 1.2x equals 0, sorry about that guys, went a little haywire. Alright, let's try that again. Number 5. 1.2x equals 0.2x squared plus 0.6. Now, a couple of things that are different about this one. One, it's not in standard form. And two, we have all these lovely decimals. So good news is we can fix both of these issues. The first issue is that we can actually get rid of the decimals. So if you'll recall from previous math classes, if you are trying to remove a decimal, you simply multiply. So because these are all 1.1 and 2 tenths, 2 tenths, 6 tenths, that's what that tenth is right there. All we have to do is take and multiply everything by 10. So if we multiply this whole problem by 10, that would give us 12x equals 2x squared plus 6. Okay, and the only reason I'm actually doing this is because this is not a word problem, which means we're going to give our answer as exact as possible. If this was a word problem, I would leave the decimals and just let the numbers fall where they lie, just wherever they fall. But I want exact answers, and it's going to be a little difficult to do that with decimals. So the next thing we're going to do is we're going to move this 12x over here in between the 2x squared and the 6. So to do that, I'm going to have to subtract it. So that's going to give me 0 equals 2x squared minus 12x plus 6. So again, simply getting things in standard form. And whether it's 0 equals or if it equals 0, it doesn't matter, okay? They're still in standard form, and we can still easily find our a's, b's, and our c's. So our a in this case would be 2, it's in front of the x squared. Our b would be negative 12, it's in front of the x. And our c is our constant, which is 6. So what I would like you to do is I'd like you to pause the video at this point, and I want you to try this problem, and when you're ready, turn it back on and see if you got it correct. Alright, hopefully you're ready to see the answer. So I haven't quite finished it, but I want to see if you've gotten this so far. So you should have gotten 12 plus or minus the square root of 96 over 2. So if you got that part right, give yourself a little check so I can see that you did get that on your own. And then you should have simplified 96 down, and it ends up being 4 square root of 6. And notice over here is where I've done my work for that. It's 16 times 6. Now, this still isn't quite done. So if you got that, though, that's awesome. Give yourself a little check. The last thing you have to do, if you didn't do it, is make sure these numbers here have no common factors. And 12, 4, and 2 can all be divided by 2. So 12 divided by 2 is 6. 4 divided by 2 is 2. I don't touch the square root of 6. Okay, that's an inside number. You leave them alone. Now 2 divided by 2 is 1. And typically speaking, we don't leave it as something over 1. So I'm going to erase that 1, and that would make this my answer. 6 plus or minus 2 square root of 6. So if you got that part all the way down to the end, give yourself a little smiley face down in the corner so I can see. And good job. Awesome. If you can get that problem, then you're set. Alright, so now we're going to look at the discriminant. So the discriminant is just a fancy word for whatever is underneath the radical. So for b squared minus 4ac, when we look at the quadratic formula, that is underneath the radical. And what this tells us is how many and what type of solutions we have without having to do all the work. So first of all, if our discriminant b squared minus 4ac is greater than 0, meaning it's a positive number, you can expect yourself to have two real solutions. And these solutions could be rational or irrational. So what I mean by that is if you look back up here at number 2, notice our discriminant was 16. That's a perfect square. And that means our answers were 0 and 4/3. Those are rational numbers. Okay, now number 3, our discriminant was 40. And notice 40 was not a perfect square, and that's why we still have a radical left in our answer. This answer, square root of 10 over 5, is irrational. So that's one thing that the discriminant tells us, rational or irrational. Now, on our graph, this looks like two x-intercepts. And it doesn't matter if the graph is opening up or reflected down. If that graph crosses twice, then you have two real solutions. Now, when we're looking at the discriminant and it equals 0, that means you're only going to get one solution. and that one solution, that one real solution, will be rational. And notice that's where the vertex hits the axis. And again, it doesn't matter if it opens up or down. What matters is that there's only one time it touches. Now, I don't think we had any examples that happen like that. But if the discriminant equals 0, what would happen is you wouldn't have the plus or minus. You would just have whatever's in front. Okay, and then finally, when we get our complex solutions, this is when our value underneath the radical is negative. So when b squared minus 4ac is less than 0. And they're always going to end up being our complex conjugates. So notice here on this graph, this is the real plane. This is the Cartesian plane. This graph never intersects the x-axis. Okay, so remember, it's in the complex plane, it gets flipped around in that other dimension, and we end up with two complex solutions. But in the real world, in the real plane, in the real complex, in the Cartesian plane, there are no solutions when you graph the function. Okay, so down here, real quick, we're going to try some of these. So starting with the number 6, we're going to have 2x squared plus 5x minus 3 equals negative 6. So on this particular problem, the first thing we're going to do is we're going to make sure that this is going to be equal to 0, because you can't use the discriminant until it equals 0 and is in standard form. So I'm adding the 6 over, and I'm getting 2x squared plus 5x plus 3 equals 0. So now, just using the discriminant, b squared minus 4ac. I don't care about the rest of the quadratic formula at this time. That's a lot of work that I don't need to do. I'm simply going to plug in what I know. So my b is going to be in front of the x, my a is in front of the x squared, and my c is in front of the 3. So that's going to leave me with 5 squared minus 4 times 2 times 3. So 5 squared is 25. 4 times 2 is 8, times 3 is 24, so I have minus 24. 25 minus 24 is 1. 1 is a perfect square. Okay, so first of all, it's positive, which means I'm going to have 2 real solutions because it's positive. And second of all, because it's a perfect square, that means my solutions are going to be rational. So there's 2 things I know, which means if I wanted to, I could solve this by factoring because it's, they're rational. All right, number 7, 4x squared plus x plus 6 equals 0. So again, the first thing I'm going to do, make sure it's in standard form. It is, and I'm going to use my discriminant, b squared minus 4ac. So again, that's the a. The b in this case is a 1, and 6 is c. So when I fill this in, I'm going to end up with b squared, which is 1 squared, minus 4 times 6. So 1 squared is 1, and then we're going to have 4 times 4, which is 16, and then 16 times 6. So this ends up being negative 96. So that is negative 95. And negative 95 underneath a radical means we have 2 complex solutions. Now, I don't know what those complex solutions are, but I do know they're going to be complex. They're going to have an imaginary in them. Okay? So I want you to try number 8. See if you can figure out how many solutions based on the equation I'm going to give you. So 3x squared minus 22 equals 3x. Go ahead and pause the video now, and when you're ready, turn it back on to check. All right, hopefully you're ready to check your answer. So the discriminant is 273, and hopefully you check to see if it's a perfect square. So first of all, 273 is positive, so that means you should have put that you have 2 real solutions. And then if you tried to take the square root of 273, you end up with a decimal. It's something like 16.5 something. So since it's not a perfect square, this tells me my solutions are going to be irrational. I'm going to have a square root left that I'm going to simplify. So again, if you got this one right, give yourself a little smiley face down in the corner. If you got it wrong, then fix it, and don't give yourself a smiley face. Okay, so that's the discriminant. Again, this is just kind of a shortcut because sometimes we don't actually need to know what the answers are. We just want to know what type of solutions we have, and you don't have to do all the extra work to get there. Okay. All right, last thing we're going to do is context problems. Everybody's favorite, I know. Again, the quadratic formula makes them really easy. It's a lot easier with the quadratic formula. So number 9 says the demon drop at Cedar Point in Ohio takes riders to the top of a tower and drops them 60 feet. A function that approximates this ride is h equals negative 16t squared plus 64t plus 60. So this is really important, the fact that they actually gave us an equation. So the first thing I'm going to do is I'm going to write that down. H equals negative 16t squared plus 64t plus 60. If they give you an equation, they've done half the work for you. And they tell you h is the height in feet and t is the time in seconds. That's important to know. About how many seconds does it take for riders to drop 43 feet to the nearest tenth? So 43 feet is a height. We are going to plug that in for h. This is h equals 43. So right here, 43 equals negative 16t squared plus 64t plus 60. Now to use the quadratic formula, it has to equal 0. So to do that, I'm going to have to subtract 43 from 60. So 60 minus 43 is going to be 17. So I have negative 16t squared plus 64t plus 17. So now I can use my quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, I'm using x, but really I should probably be using t because I'm solving for t. I want to know the time. So when I'm plugging this in, again, I have t squared is my a, 64 is my b, it's in front of the t, and constant is c. So t equals negative 64 plus or minus the square root, 64 squared minus 4 times negative 16 times 17, all divided by 2 times negative 16. Now we got a lot of big numbers here, but that's really okay. Again, the quadratic formula makes things a lot easier because all we're going to do is start chugging. So this time I'm going to type in this whole underneath in my calculator. I'm going to type in 64 squared minus 4 times negative 16 times 17. I'm not going to do it piecemeal. So when I type that entire thing into my calculator, and hopefully you're doing it with me, you should end up with 5,184. Okay, I do need to see that step. I need to see what's underneath the radical. I need to see the discriminant. But I don't need to see every little piece if you don't want to show that. So on the bottom, I have 2 times negative 16, which is negative 32. Okay, so now we're going to start cleaning some things up. So the first thing I'm going to check is the square root of 5,184 a perfect square? So when I take the square root of 5,184, it is. So that's super exciting because that means my problem may not be too difficult. So negative 64 plus or minus the square root of 5,184 is 72, all divided by negative 32. So the last thing we're going to do is we're going to break this up. Negative 64 plus 72 over negative 32, and negative 64 minus 72 over negative 32. And you can at this point type all of this in your calculator if you'd like, or you can do it by hand, whatever you need to do. So negative 64 plus 72 is going to be 8, and 8 divided by negative 32 is, positive 8. So that ends up being negative 0.25. And notice I am doing decimals because up here in my problem they say that I can round to the nearest tenth. Okay, so that's something I'm probably going to want to do. So now that being negative, not super helpful. So I'm hoping my second answer is not negative. So negative 64 minus 72, negative 136. And when I divide it by negative 32, it ends up being 4.25. So that's super nice because that's positive, which means I'm going to toss out this negative answer. I can't have negative time, but I can have positive time. So it takes about 4.25 seconds exactly 4.25 seconds for the riders to drop that many feet. But they said to round to the nearest tenth. So even though this is exact, I'm going to do what the problem says. So in my answer, I'm going to say it takes approximately 4.3 seconds for riders to drop 43 feet. And notice all I'm doing is rewording the question with my answer embedded in it. Okay, so again, quadratic formula makes word problems a lot simpler. Okay, so number 10. Now, notice this one, I'm looking at the equation immediately. As soon as I look at it, the equation's popping out. I have h equals negative 4.9 t squared plus 27t plus 2.4. Now, I can choose to keep it as decimals, or we can get rid of the decimals. It's really up to us. I'm going to leave the decimals this time because it's a word problem. So we have a water balloon being catapulted into the air so that its height in meters after t seconds is this function. When will the balloon hit the ground? Hit the ground is a height of 0. It's when it's on the ground. Okay, so we're going to take and we're going to fill in 0 for h, which is particularly nice because that means this is already in standard form. So since it's in standard form, I can go straight to my quadratic formula. So instead of using x, I'm going to use t equals negative b plus or minus b squared minus 4ac all over 2a. And again, we have our a, our b, and our c. So our time is going to be negative 27 plus or minus 27 squared minus 4 times negative 4.9 times 2.4 all over 2 times negative 4.9. So again, word problems, decimals are okay. Normal problems, probably want to get rid of them. Alright, again, typing this whole thing in my calculator. 27 squared minus 4 times negative 4.9 times 2.4. And I hope you're doing this with me. So we should get 776.04. Now, if I did it wrong, please let me know because we'll have to fix this video. Alright, 2 times negative 4.9 is negative 9.8. Now, here's the great thing. At this point, we can just break this apart and put negative 27 plus the square root of 776.04 over negative 9.8. And then we can put negative 27 minus the square root of 776.04 over negative 9.8. We can put that whole fraction in the calculator. So remember, our fraction key, you're going to use the alpha key and then the y equals. And that ends up being f1. And that's how you get your fraction. So alpha f1, and we're going to type in that whole thing, negative 27 So when you did that, I hope you got negative 0.087 something something something. Okay? If you didn't, please let me know. Maybe I made a mistake. It happens. And then we're going to type the same thing in on the other one. And that's minus. So that's approximately 5.5977 ... Okay, now they don't tell us what to round to, so when they don't tell us, we typically try to round to the nearest hundredth, so meaning 2 decimal places. So right here and right here. Now, not both of these answers make sense. The negative answer, we need to toss that. It doesn't make sense whatsoever. So we're going to keep the positive answer, and we're going to say the balloon hits the ground in approximately, now 5.597, we look at the 7, it's bigger than 5, so we round up. So we're rounding 59 up to 60. So this is going to be 5.60 seconds. And that would be my final answer. Okay, so now the last thing you have to do, you're done listening to me talk, But I do need you to go through and answer these problems on the very back page. So you have a few more problems to do. Try your best, and we will go over them tomorrow. Make sure you show your work.